Hi everyone, this is Dr. Swaminathan SM. Now I am going to discuss about the topic combinational logic circuits for examples of combinational logic design. So first we will give the small introduction about the topic. The outline of this today's topic is combinational logic versus sequential logic. So first, what do you mean by combinational logic? That means combinational means you are given the input and getting the output. So without any feedback, you are given the input and getting the output. That is called combinational logic. Next, using the CMOS. CMOS, already we discussed about the CMOS, is the combination of PMOS and NMOS. That is called CMOS. So using the CMOS and PMOS combinations, like parallel or serial combinations, we will discuss about the NAND NOR gate and also adder, that is half adder or carry skip adder, and following with this encoder, decoder and mux. These are all the examples of combinational logic circuits. So first, so this is the diagrams about the combinational logic versus sequential logic. So here we are using the logic circuit, that is first diagram. From this diagram, the output is given as a function of input. So output varies based on the function of the input. Next, sequential logic. If you go for the sequential logic, the output is the function of input as well as previous input. That is called the sequential logic. And next, the CMOS circuit that is defined, the upper side, that is called the PMOS. That is PMOS means that is a pull-up network. Suppose if you given the input either 0, it works. And that is inversely based on the PMOS, the NMOS is working inversely. That is, if you are given the input to 1, then NMOS is working condition. So this is the CMOS combinations. So first we will discuss about the parallel and serial combinations. So here first circuit, you look at the first circuit. If A and B, so both are AND gates, then Y is equal to X. Okay, so that is the best thing we need to consider. Y is equal to X means if both must be enabled, that is called A and B. And next, the combinations Y is equal to X if the combinations are parallel. So if A or B, so if any one is enabled, the output will be conducted. So the output will be conducted means X is the input that is given as a output. So this is the combinations of series and parallel. And next, the same combination. So if A bar and B bar, that is the PMOS logic. And if A bar or B bar, that is also the PMOS logic. So PMOS and NMOS both are working in the low condition, that is input is 0. So P for bubble, that input is 0. And next to the combinational logic, that is based on the combinational logic's function based on the De Morgan's theorem. So what do you mean by De Morgan's theorem? A plus B the whole bar is equal to A bar into B bar. So pull up network, that is the dual of the pull down network. So A B whole bar is equal to A bar plus B bar. So you can say both that is plus is converted into multiplication and multiplication is converted into plus. So an example of the NOR gate, if NOR means you just remember NMOS is parallel. If NMOS is parallel, PMOS is series. And same thing vice versa. If you think about the NAND gate, NAND gate means you just remember the keyword dot NS. Dot NS means nothing but NMOS is series. If NMOS is series, PMOS is parallel. And next, the complex logic gates, we will discuss about the combinational logic gates. So OR and inverter. So you can discuss about the complex logic gates. First, you need to consider the basic conditions. So what do you mean by conditions means if PMOS is series. If PMOS is series means what? That is NOR gate. So B plus C into A plus. Next, if same thing, so that is converted into the another portions. Okay, so based on this, you can convert into that BC. So BC, NMOS is parallel means that is NOR combinations. So Non-combination means B plus C the whole bar into A plus D. So that is the condition. So you have to achieve this complex logic gates. And next, the complementary, we need to think about the complementary. PMOS is pull-up network and NMOS is pull-down network. So if pull-up off means that is floating conditions, pull-up on means that is one condition. That is one means if it is pull-up is on. And same thing for the other thing. So NMOS operations, what are the NMOS operations? We think about the NMOS operations. So NMOS is nothing but, already we discussed the NMOS. So body is commonly that is tied to the ground. And when the gate voltage is low voltage, P-type body is the low voltage. So source to body or drain to body, the diodes are off. So basically the transistor is off conditions. So this is the NMOS operations. And the examples of the combinational logic we'll discuss about the adder. Adder means half adder. Half adder means if two inputs are given, half adder. Three inputs are given means that is full adder. And carry skip adder. If it is needed, you can add the carry. That is carry save adder. If it is not needed, you can skip the carry. That is carry skip adder. Carry lookout adder means it is forward adder. Next, subtractor. Same thing. Subtractor means half subtractor, full subtractor, like this. Multiplier means that is inside the multiplier you can use the adder. So for example, 5 into 2 means you can add the 5 2 times, then you can get the output 10. Then 2 times you can add the 5 means also the output is 10. So inside the multiplier you are using the adder. For application oriented, you can make the literature survey which one is the best adder for the multiplier, and same thing for the divider. And the next, mux demux. Mux means many to one, many input given as a output, many input given input that is converted into only one output, that is called mux. Demux means opposite. And the encoder decoder both are working in the enable disable pins. If it is needed, you can use. So encoder means n output. So 2 power n is to n. 2 power n is the input, n is the output. And next, the frequency divider. Based on this, you can divide the frequency range 2 power 0, 2 power 1, vice versa. So this is the full adder design. So sum carry, we need to design the sum carry. So sum means full adder A XOR B XOR C in. And carry out means you can convert, that is AB plus BC in A plus C in A. So AB plus BC plus C in A. So C in, that word define the C in. Why it is called C in means, because suppose if you connected continuously for full adder, suppose you take two full adder, first full adder connected with the second full adder. So first full adder carry out is given as a input of the second full adder. So it is mentioned as a C in. Next, carry skip adder. So here look at this, the carry is skipped from one stage to another stage. So this is the mux. Mux means, so already I discussed about the mux. So if the input that is D0, 0 or D1 is 1, for example, you just select the pin. So S is equal to 0 means D not given as a output. So D not may be 0 or 1. Next, S is equal to 1 means D1 is given as a output. So D1 may be 0 or 1. So this is the combinations of mux. And next, for the 2:1 mux, you can use for same thing for decoder. So decoder we are using A1, A0 based on this word bin, and again it is used for the NAND gate, OR gate and NAND gates. So this is the decoder. And the assessment. So you need to design the full adder for two half adder. You just use the two half adder. Based on the two half adder connectively, and you can use the full adder. And next, the derivations about the 2:1 mux. So you can use the 2:1 mux. Y is equal to D0 bar into S0 plus D1 into S1 bar. So you can both the combinations. So S0 bar means 0. If 0 is enabled means first one. So S0 bar into D0 plus S1 into D1 is equal to Y. So that is called the mux. Encoder and decoder means based on the enable disable pins it is working. And combination logic, sequential logic comparison means you can get the combination logic means if the input is given, just you can get the output. Sequential logic means you can connect the feedback or state register. Again, the output is given as a input. That is sequential logic. NMOS and PMOS means if NMOS means if you are given the input 1, NMOS is working condition. PMOS means if the input is bubble, that is zero, that PMOS is working conditions. So this is the assessment. Next is the summary. So this session we will discuss about the combinational logic versus sequential logic concept, and adder, subtractor, and the divider, and the multiplier, and mux, demux, then uh, encoder, decoder. So these are all the things we discussed in the class. So thank you. Suppose if you have any doubts, kindly connect.